I'm Michał. I've been doing mobile apps for some time. Right now, I'm working in Waymo. I'm a full stack developer. I do a bit of mobile apps, a bit of backend, like a bit of everything. And I'm here today to talk about how to get all this AI stuff into directly into your mobile app. So like the story is ever since ChatGPT first came out, I was like blown away by this. And the first thing I was curious about is how can I get this whole ChatGPT running inside my mobile app, and how can I get this like to interact with my users, and how can I get this to react to what the users are saying and trigger certain functionality in the app. So hopefully it'll be a bit more clear how to do that, and it's all based on my like personal experimentation. And having said that, I'm a developer. I'm not an AI researcher. Do we have some AI researchers here? No, that's not very good, because you know I can explain everything like from a practical point of view. But like the mathematics and like the theory behind this, like this is not my expertise. So I was hoping that there will be someone knowledgeable. Yeah, let's proceed with this. Yeah, so a couple of things we're gonna cover today. Oh, I was told not to do this, and I just did it. So I'll just stick here. So first, we're going to talk about we've got all of these awesome APIs. They're very easy to use. It's just like one simple HTTP request. So like, why do we bother at all with bringing all of this into our mobile app? Then we're going to dive a little bit inside the theory, but fear not. I'm not going to go into these academic details like. As you read Twitter, like you can see all of these AI experts which show all of these complicated mathematic formulas. So I'm going to explain it in a very simple way, and I'm going to show you how you can do all of the basic stuff, like training your own model, how to fine-tune the model, and how to run local inference using off-the-shelf tools right on the hardware that you own, without buying expensive GPUs and stuff like that. Then we're going to talk about function calling, which is actually the what makes an LLM talk to your app. Then we're going to see how it works in practice. So first, I'm going to show you how to build a model that weighs 20 megabytes and can use something similar to function calling to react with your app. And then I'm going to show you like how if you wanted to proceed with this in a real production app, then the second demo will cover that. After that, I'm going to show you how to fine-tune a model, right with your phone. So like there will be a little bit of code which you can take a photo of, and you can do everything from your pocket. And then some trade-offs and the boring stuff. Yeah, so when you write like an AI app right now, if you go to Google Play or the App Store or some of the popular AI apps out there right now, the way they work is they call some kind of a cloud server like Claude, Gemini, or any other, and this works. This is easy, but the thing is, every single request which you send, it costs you money. Like right now, this is dirt cheap, but all of these cloud providers, they're trying to get everyone like hooked in right now, and this is going to get more expensive later on as it gets commodified. Also. There are issues with data privacy. Like all of the data you're sending to these cloud people, they're carefully watched, and they are using this to train their models. Like you don't really know what they are doing with this. Like if you take a look at what OpenAI is saying, I recently read somewhere on Twitter that OpenAI would like a cut of of your products after you release them. So like if you invented something with OpenAI, then you know they use their tools. So like they also would like to look into it. So if you run things locally, like you own 100% of it, and it's users don't need to worry about their data, and it's especially important because we are in Europe, and our data processing laws are much stricter than they are in the United States or in Asia, for instance. So if you're working on an app which works under the GDPR laws, local data processing is especially important. Yeah, so there some of the common things which mobile apps do. So one of the most common thing that you want an AI model for inside your app is to parse user commands. So I don't know, you have a chatbot, and the chatbot speaks with the user, and then after the chatbot receives certain command, then it should do something in your app, like trigger an HTTP request or lead them to a certain screen or things like that. So usually, like if you want to use like a cloud model for that, like you can, but like as your app scales, like it's going to cost you a lot of money. And like from my experience, like if you're doing a new product, it's best to stick like with the simplest solution. So like I would even take a step further. If for instance, like you want certain thing to be happening in your app after like someone says a magic word, then you can even use simple regex for this. Like maybe you don't even need an AI model for this. Like I've known like a startup which runs Ruby courses, and that's pretty much what they did. In order to check if someone wrote correct Ruby code, they used a regex. They didn't use a compiler or interpreter. So that was the funny thing. And so first ask yourself the question: what is good enough like for a product? Then text classification, similar content. Like you've got open source models which work in AI Core or ML or Core ML on the iOS side. They're free to use. You can use them in commercial products as well. And they don't really bring much more overhead into your app. Everyone has these advanced phones nowadays, which have these AI tensors and AI chips like in their running in them. So it's they're fast, they're optimized, they're free. So it's worth to use them. So the only reason which like cloud stuff beats like local stuff is deep reasoning. Like you probably won't get that far on a locally running model. So like if your product needs like some deep reasoning inside across like multiple websites or advanced understanding of some large documents, that's the reason you should like think about including cloud-based models into your app. So just to give you some perspective on how much these models weigh. So like 1 million parameters probably weighs around 4 megabytes, and but actually before that, let's like what do these parameters mean like in a model? Like that was one of the first questions I asked myself, because like people all of these models like are defined like 32 billion, 100 billion, 200 billion. Like what do these millions and billions mean? So if you imagine a model as a chest, and then like you open that chest, you're gonna see some numbers like scattered across multi-dimensional space, and each of those parameters are pretty much numbers. So like words or tokens which we use to converse with the LLM are scattered across that multi-dimensional planes, and they are characterized by those numbers, and those numbers represent the coordinates, and those coordinates align across layers, which represent different different reasoning in those models. Like this may sound a bit abstract, but this will be a bit more clear as we dive into the code. The transformer architecture, like the small model I mentioned you, the 20 megabyte one, will run on the same architecture that powers ChatGPT. So before the transformer architecture, we had neural networks, which also understood natural language. We had natural language processing algorithms. And things like that. But the problem with this approach was they looked at words as separate entities, and with transformer and self-attention, we've started looking at relationships between the words itself. That's how the models mathematically understand what are we talking about. So, for instance. The models probably don't understand the notion of love or what an animal is, but they do understand by looking at much big pieces of text that like cat and dog and feline probably are mathematically related to each other. But like we all know that these are animals. How does a model convert your question to an actionable answer? So first, all of the words that you say are converted into numbers, which are vectors, which represent those coordinates in that multidimensional plane I talked about. Then the second thing is the attention. So. The model looks at the relationship of all of the words between each other, and then a neural network analyzes these relationships, and that's how they come up with this difficult math underneath to correlate them. Of course, what you see right now is very simplified. But this is how those parameters look in practice. So these are this is nothing else but just vectors, like very big vectors. Because like here we see three-dimensional vectors. But like in the real model, this would be like hundreds or even thousands of dimensions inside each vector. And that's how they understand the reasoning and the relationship between all of these words. Yeah, so like the relationship between words is important because like here in this example, bank means a totally different thing, and that's how the human language works. Like the context between everything is very important. Yeah, so we've got the models, and how do we make them smaller? So all the parameters, all of those numbers, they're usually floating point numbers. They're 30 dB floating point numbers. So like the first thing is we can just cut the numbers, make them less precise, and that's precisely what's called quantization in the professional world. So like when you go to Hugging Face, like Hugging Face is pretty much the GitHub of the LLM models. That's where people, like in GitHub, people upload their code, and on Hugging Face, people upload their LLM models, and not only LLM models. So the first thing, like when a big model comes out, like people tend to run quantization, so you can run them on a lower end device. For instance, like I'm recently playing around with self-hosting some models, and I bought a couple of GPUs and stuck them together in a cluster. I convinced my wife that this is a very nice home decor improvement, and you know, we get the heat. We can heat our house from the excess heat coming from those GPUs, and that noise, like it's like for me it's music, for her not really, but yeah, it works. Yeah, so when you want to self-host a model, like quantization and cutting the precision of the numbers will be the first thing you're going to look into. The second thing is remember I mentioned those layers, and the layers that represent like different meanings and relationship between those words. So, for instance, maybe you're not interested in your model having some ethical layer or an animal layer. So that's the second thing that you might want to do to cut the model. But like in practice, like 90%. Like 90% of you, like if you would like to play around with this, like you're going to try with quantization, because this is pretty straightforward. Like pruning and weight tying, this is pretty advanced stuff, and I won't lie to you, like I never did this. I know this exists, and like maybe someday, like if I upskill, then I'll try it. Okay, so we know how these models work, how they understand what we say, and the next question is how do we make them talk to our app? So that's the mechanism which is called function calling. So basically, how it works is that you say to the model, "Hey, I'm running an app. I have this functionality to, for instance, like following this example, to give reminders." And I want you, whenever you feel like it, you feel like it from the context of the conversation between you and the user, I want you to call this function with those precise arguments I say to you, and you let me know when you want to do this, and then the model, whenever they see a moment that they want to execute this function, they send a special character sequence that indicates a function call, and that's your window of opportunity to parse the function arguments and to call actual functionality into your app. I think Peter mentioned that you can have structured content inside Gemini API, and Gemini also supports function calling. So you can configure functions inside Gemini API as well, and then you can also specify that, hey, I want this function to return this exact schema after it's executed. So this is your way of actually capturing this moment when the user wants to interact with your app and do something and then return some results. Yeah, so the model's job is pretty much to catch that moment, to understand the user's intent, and your job is to clearly define what the functionality is, clearly define the arguments, and then show the result to the user. Yeah, so that's an example of how it works, but we'll get to that like in some code examples. And now the important question is like, which model is the best for function calling? So for the purposes of this presentation, I trained a model on my laptop, which has 800,000 parameters, and it's as you will see, it will work for very simple queries. It's going to respond in JSON as well, so like you can teach a model how to speak in JSON in very little resources, However, like this will be good. This will go for very simple queries. But also Peter mentioned that about the orchestrator pattern. So that's also that's a very popular way of routing like stuff between like your local model and your cloud model. So you can have a local model running in your app, which weighs like 20 megabytes, and if it understands what the user wants to do, then that's awesome. You can do it offline and without any any request. But if it doesn't understand what the user wants to do, then you can forward the request back to either a stronger model running in your app, which you will load on demand, or to a server, and like having in mind that every request costs you money. Google, aside from Gemini, also released some locally running models, and one of them, which is particularly good at interacting with your app, is called Function Gemma. So this is a specialized version of Gemma models, which is specifically designed to understand JSON, and it's not meant to actually converse with your users, but it's meant to, like, if you have an application which interacts, for instance, with your smart home. So like it's meant to understand when the user says, "Hey, I want to turn the light off," or "I want to set my AC to 70 degrees." Things like that. So it's very small. It weighs only like a bit over 100 megabytes. So it doesn't bring much overhead, and it's very accurate. It's like from my experience, it's over 80%. It responded like to over 80% of my requests. Then you have the cloud models. They obviously have they're running on powerful hardware, so it's a very good chance that they'll understand what your user wants to do. Okay, so enough talking. Let's see some code. So the first demo is about how to train your model using PyTorch, using open source tools, and how to consume it in the app. Okay, let me. Oh, there it is. Yeah. So also don't worry. Right after this presentation, I'm going to make all of this open source, and there will be a QR code for you to scan, so you'll be able to see it. Yeah, so that's who's familiar with Python here? Perfect. This majority. Okay. Yeah. So I'm not going to go like deep into how those tools work, but like with like PyTorch is the leading framework for deep learning, and if you want model fine tuning and things like that. So that's pretty much that's pretty much all of the code which you need to run to train your model. That's like 400 lines of Python code, and you might ask, like, where's your data set? Because that's pretty much the first question you get when you say, hey, like, I have an AI model, and the main question is about your data quality and like how do you get it? So now in the times of LLMs, there is this move which is called syntactic data. So you can ask other LLM to generate data for you. So this is what I did for the purposes of this talk. So I've had another model, vibe code, a Python script which generates some data for me. Here. Like we'll have a very simple model which understands like very simple JSON commands, like show me an alert, or refresh this page, or navigate to this area. So the first thing I wanted to do is to show the model a diverse set of JSON commands. But you have to remember this. It's not like this model understands JSON. Like it's going to work in a way that we're going to show it a bunch of JSON strings, and then it's going to try to follow those patterns. And it's not going to do any semantic analysis or things like that. So these are the commands which we'll support in the app, and these are some words that go along with which another LLM generated for me. So this is the cool thing about living in modern times. So here's how the app looks like. It's written in Jetpack Compose, so it's cross-platform, like a true full stack would do. This is so the code which is responsible for inference is enclosed in this class. I was also curious if I'll be able to get an LLM to generate the necessary code to do that for me. So yeah, it works, and it's just a few lines of like 300 lines of Kotlin code, and yeah, let's see how it works in practice. So this is an Android emulator. So first we load the model, and we can type some commands. Like let's say I'm going to type it to refresh the page. Refresh page. Then it's going to parse the command. Yeah, so that took fast. It understood. So we also so the purple field shows the exact JSON which the model sent us for the request which we written, and the green shows our app's understanding of it. Yeah, that was simple. So now let's try something harder. Show me an alert saying hello. So we're going to run it. It's going to probably take some time to. Oh, so it's shown an alert, but the text is wrong. So like it partially understood it. So that's the thing I was talking about. Like you showed a bunch of JSON files. So like it probably took one of the JSON files which was in the data set, and it like probably mixed some words together and said, okay, like that's how JSON works, right? No, it's not right. And yeah, so I can also show. I can also tell it like make that page fresh. We're going to run it and see. Yeah. So okay. So again, it understood some command. So right now it would navigate me to a different screen which doesn't exist in the app. Yeah, so that's so you know our model weighs 20 megabytes. It's like I did it in like 3 hours. It understands something, not much. So probably like if I train it with a bigger data set, then it would be better. But yeah, let's try to type it something that it doesn't understand. Like, who are you? Let's see. Unrecognized. Okay, so that's actually very good, because now it openly admitted that it doesn't understand this command. So now this is a chance for me to actually route this to a more competent model. So this will be a chance for me to load up some serious model who is capable of some reasoning, or to fire up request to some other model. Yeah, so it's as you can see, like it's possible. Like if you have the right resources and you have time to generate a data set, to test everything. Like there are tools in here, and you can run everything without any dependencies whatsoever. However, if you were to go to production with an app, then there are better ways to do this. You don't have to create your own data set from scratch. You can use an existing model which already understands JSON much better than the model like you would create by yourself. And there are also existing libraries which already do all the heavy stuff for you. Llama CPP is like the leading open source inference framework. It handles many different model architectures. I haven't interacted personally like with an architecture that doesn't support yet, but it doesn't mean that it supports everything. It's written in C++, so you can use it pretty much everywhere, where you can run C++. We're going to do this example again, however, with a better model. So let me go back. Let me go here. Yeah. So the difference between the model I created myself is it weighs so little because I've stripped everything unnecessary from it. If you want to create a specialized model for your app, if you want your model to just tell you which screen to navigate or tell you when to refresh the page, you probably don't want this to converse in Chinese language or speak German or do any kind of advanced reasoning. You only want this to output certain commands based on this set of data. This model is different, however. This model wall it's not meant to do any kind of conversation with you, but it can respond. It can respond in a way that you specify, like if it doesn't understand something. Okay, so like let's try this alert thing again. Show me an alert with message test. Oh, it didn't work. Let's try that again. Show me an alert saying test. Oh, it didn't work. Saying. Oh, it worked. This is an alert saying hello. Yeah, so this is technically true. So as you can see, like the difference between this model is like it can respond somehow, like if it doesn't understand something. Let's try with a different example and show me a pop-up saying hello. The funny thing is, yeah, it tested this exact prompts like last night, and they all worked. That's like the demo gods are not favorable today. Yeah, so it's and also what you can see is that model responds much faster than the custom written one. And it also, despite being larger, it also may use a little bit of it also may use the resources a bit more efficiently. Okay, so let's see how it's implemented under the hood. So that's the demo number 2. So it's in the Compose app. There's a bit of a native wrapper. So that's the bit that actually does the inference, and where you can set various parameters such as the system prompt and parameters such as like top K, temperature. When you do a custom inference, these where are they? Oh, there it is. So let's search for temperature. Oh, there it is. Yeah, so that's how you set the temperature then and the top K sampling. So if the temperature tells how how deterministic you or how creative you want your answers to be. And the top K also determines the relativity of the next tokens predicted. So imagine this: like when the model runs inference, it has some predictions based on the next what the next token should be, and the more you give the top K, it's like the more tokens it will have available to select, and the less it will be much more focused on what the task at hand is. So like when you design your own apps, which even cloud models make it available. So like when you design like your own app, like you'll want to play around with this a lot. And yeah, so how do we define the functions? So that's remember when I talked about like these special tokens which output. Oh, there it is. Start. Store function call. So that's pretty much how the LLM defines like the start and end of a function call. So like you converse with your user, and after a certain point, it's going to output, hey, start this function with this name and these parameters, and then you capture these special tokens, and then that's your chance to execute the logic, and then put the results back into the context. So like if you would react like if you would use like a normal conversing model, then it would be wise to get all the results back into the context so that the model can interpret them and continue the conversation based on those results. However, if you're looking to build a simple app, which just reacts to some things the user said, then it might not be necessary. Yeah, so that's pretty much how you run inference. Like also like when you structure user messages, you also probably need to wrap them up in some special templates. Like different models have different templates. They want the text to be the text to be fed in. So like it's a good idea to actually analyze what kind of format do they follow. Yeah, so this model we've seen right here, like it runs on mid to high-end phones. It consumes a bit of RAM, but like it's very fast, and like it understands JSON like better than the small model I trained. Yeah, so how that's also an interesting thing. Oh, 5 minutes. Then okay, I'll make it fast. Okay, let me go to the next slide then. Let's go to fine tuning then. Okay, like you've got this great model which you found on the internet, and how do you make it understand what your app is about? How do you make it understand your app branding and the terminology that you used? So there was this genius mathematician who invented a technique which is called LoRa. So it's called low rank adaptation. So the way it works is when you want to build a model, the level of effort that it takes, it's pretty much to you can compare it to like raising a child until it's 20 years old. So you have to invest a lot of resources and a lot of time. And with LoRa fine tuning, it's you guys watch The Matrix, right? And you remember the scene where Neo is like, "Hey, I want to learn jujitsu," and they plug a thumb drive, and it's like, "I know jujitsu now." Yeah, so that's pretty much how LoRa works. So you run you can run a tool. You can give it some example prompts and answers, and then you get back a file which you can then load into the inference framework, and then it will understand perfectly what your app is about, and you can also feed it some concrete examples and whatnot. What's also awesome about this, like for instance, you have an app which has a running local model in there. You can like you have no way to change the local model there, but you can, for instance, download this because these extra files they're pretty small usually. They're like 500, 50 or 100 megabytes. So that's your way, for instance, to customize stuff for every user. Like your app could also be your app could also be like fine-tuning models, like based on each individual user's interaction of on your app. So I highly recommend, like if you're going to do this, use the tool which is called Onslav. This is like I don't know what they're doing, but like I feel sorry for those engineers who had to do like this level of optimization. But they also publish ready-to-use Google Colab notebooks, which take you through step-by-step baby steps on how to do it. Yeah, so the fine-tuning process is pretty much like this. Like you feed your model like something like this, and many times repeat it, and then your model becomes smarter. You can also like do it on your laptop. So my slide got cut off, but don't worry, this code will be available open source. Wait, where it is? Oh, there it is. Yeah, so like if that code at the bottom was showing up, you would be able to take a photo with your phone, open Google Colab, and run this phone and train your model by yourself, right in your pocket. So this is just like this how easy it is to use those tools. Yeah, so that's the result of fine tuning. Like if you give it some LLMs, like they love examples. So like if you feed it much more examples of how to interact with your app, with your functions and with your app, it's going to work much better. Yeah, so that's a break of how the model size interacts like with your mobile phone and how much overhead it gets. So like the rule of thumb is you take the model size, you multiply it by 3, and that's pretty much how much RAM it's going to consume. So like it grows pretty much very high. Nowadays, like people are making models like bigger and bigger, but there's going to be a time where all of the compute power is going to be bought by all of these AI companies, and we're going to make models much smaller, and it's happening already. Like the tools are much more sophisticated, and it's getting there. Okay, so how do I get the production with all of this? So like I highly recommend the MediaPy framework by Google. It's an SDK which runs on Android, iOS, and web, and it provides you with a very simple interface to use for inference. Llama CPP is something which we've covered here. But like if you're not afraid of C++ and bringing a little bit of overhead into your project, then this is probably the way you want to go. There's also there are also TensorFlow libraries for model inference. ONNX, I know that some people are using it, but I personally didn't use it, so like I don't really know if it's good or not. I've just seen people using it. Yeah, so we've already seen that. We don't have much time. Yeah, so let's jump to some takeaways. Yeah, so I think the most important takeaway is you can do this. Like when when I first started to become curious about it, like I saw all of these complicated math. Like I'm an old guy now. I'm 36, so like I graduated a long time ago. So like my math is not that good anymore. But like you can do this. The math is also not very complicated. Like if you paid attention on linear algebra and then the matrix stuff. So. Size matters. Make sure to match the task you want to do with the model which you want to do, and this is zero cost, zero privacy. Not zero privacy. Zero privacy is when you use the API. Like this is full privacy. So zero privacy is like when you log everything. So yeah. Yeah, so and better UX, like especially like if you work in GDPR environments, then yeah, that's something you wanna pay attention to. Yeah, so here are some resources I used. Yeah, I promised that I'm gonna make it open source. So like, let me do it right now. Oh wait, that's a browser. Okay. Yeah, let me go to my GitHub. That's yeah, small model presentation. Where do you make it open source? Like settings. Danger zone. Danger zone. Oh, this one. Change to private. Oh, it's already open source. Yeah. Yeah, so it's already open source, guys. Yeah. Okay.